Vale. Physical chemistry, class 12. Okay, chapter 5. Surface chemistry to Neihsial. Discussion by the dan. Outline ka. Absorption bangaya. Then adsorption, desorption, sorption. Iti basic gyan chang de. We hit mechanism of absorption. Mechanism of adsorption. Okay, here detail we'll spend a little amount of time. Okay, so and then next is physisorption and chemisorption. This comes under types of absorption. Why hit check heavy detail study there. Why hit adsorption isotherm. Okay. Why hit Freulich isotherm. Right, and then catalyst. Catalyst study what are promoters, what are poison, what type of solution. True solution, colloidal suspension. Yeah, colloidal. Nasa takin study there. We hitcha colloidal to zoitona goal number kichi anoma. Goal number to some numericals. Ete kongi paididane. What is absorption? Mana? Masa penai the banga absorption. Itu common mama. Yeah. So the definition kaichidan yile. It's a surface phenomena. It's a surface phenomenon in which a substance is transferred into another substance. Substance danga lut sung lut chibang. Okay, example karena spongy spongy kha en leuchen. Suppose tui laka dia leuchen bang chide. Tui teng kha spongy in hip to di ma tui kha a substance tuis spongy sunga lut. Okay, so a substance is transferred into another substance. This is called absorption. Example: a sponge is drawn into water. Example nina. Okay. Suppose table tunga bongnoi ki bottle paper towel and toin land. Paper towel and toin land. So siang lechin milk dekha paper towel sunga load dio. So it's called and just soaking up of spill milk with a paper towel. Absorption. Okay. Absorption takibang chetlo study di chapter surface chemistry study di. Okay. Tu bangai chile adsorption. Absorption takibang talaw de. Absorption jo substance is transferred into another substance, but adsorption is jo substance hat surface substance dang it's attached or it's deposited. So define nila. What is adsorption? It's a surface phenomenon in which a substance get deposited or attach, deposited or attach on the surface of another substance. Absorption ra kibang no lo ma. Example paper nile. Khadna chalk, okay, chalk I pen tui ink. Okay. So ink deposited on the surface of chalk. Mana? Enle chen sunglut lo de apotham apothama ink pen belden di ma. Why le bangita ink? The substance which get deposited is called adsorbate. The substance on which adsorbate get deposited is adsorbent. So adsorbent, ink adsorbate. Example dangin dulu. A stone is drawn, DRAW, into water. Tui laga suang koi lechen, tui te suang surface ha, bel diu, sung lut thelo mana sung lam lut thelo. So here your water is adsorbate and the stones is adsorbent. Adsorbate to adsorbent meaning chang ma mata dia. So what is adsorbent? A substance on which adsorbate get deposited. What is adsorbate? Substance which get deposited. Okay, good. Next, what is desorption? Desorption to adsorption process. What is desorption? Adsorbent surface akipan ina bot khele. That process is called desorption. So when an adsorbate leave the surface of adsorbent, that process is called desorption. What is sorption? What is sorption? Adsorption bang. Okay. So absorption bang, adsorption bang. When these two processes take place simultaneously, that process is called sorption, right? When adsorption and absorption takes place simultaneously, yes, at the same time, the process is called sorption. Okay, so next is adsorption mechanism. Detailed in study only. So topic mechanism of adsorption. Enole diagram draw diba. A surface. This is the surface. The other part, the bigger part is called bulk. Surface, say suppose this molecule khatam ta. Wana bulk, yes, so bulk ale molecule khat consider na. Surface, mana surface kya nga molecule attraction khatom zo. Bang chinanin surface dang to ki track molecule dang to ki sukhang now and jolle. Okay. Anoi lama attraction tam li atung lama thil dang to attraction omlo. Ya bulk molecule in lecha. Ya tunga khatam asai ta khatam no la khatam attraction kha tamai bulk molecule. So this one is surface particle ichiham molecule ichiham a bulk molecule anole ya point bangza yam gil khadna. Okay, so the bulk molecule, let's talk about bulk molecule first. Again sabagina, the bulk molecule, this one, experiences equal and opposite forces at all sides. Yeah, bulk molecule dangte to okay, force it's equal and opposite forces. Suppose bangja equal ipa to reaction here yalang le akibang ma equal but opposite. Yeah, here penin yelama ka here penin with the same force kai pe. Ya tunga pan with the same force and ya pa to kikang to. Yelama saita yelama le. Why is ka? He is very stable. So the bulk molecule experience equal and opposite forces from all sides from the other bulk molecule from the other bulk molecules, because of which it meaning the bulk molecule, it attains stability. Okay. Keep mama even mong mama. Okay, stability. Less okay, so stability less energy. Less energy thermodynamic terms less delta H value. Okay. Nina yay surface molecule to kisay points get le. The molecule at the surface experience downward pull or forces, downward forces or pull. Vale, atung lama kai ki react pidam lo side to anoya kai suku. Pull, which makes it unstable. Which make it very unstable. A force ke balance no lo, a survive na dinga ito ngai. A tunglama ko to I reaction thai di chi azon ngai. Why takahi gas molecule here and you dem chenga pai su dir mon gas molecule teta they will form a bond, they will form a bond and again adsorption process will start. Which make it very unstable. Unstable hai chabangchi energy is very high. Energy high is delta H is high, enthalpy is high. Now, here situation taka, okay? Air molecules. Now, unequal forces to balance their air molecule tiang paitari. So, yeah, suppose air molecule khatong ki react, elama, okay, another air molecule. Okay, suppose over here another air molecule. Air molecule ka dang leoma ki makianga. Okay, keep it like this. Okay, good. So, is the air particle, air molecules get absorbed, stability is regained. Stability is regained. Stable nonta. Stability is regained. Which reduces each energy. Hello, hello. Stability again let you, regain let you, energy less. Energy is less. Tuma high energy. Okay. Initially he was in high energy, but after gas molecule adsorb, after the process of adsorption, the energy has become less. So which extra energy and evolve okay. So what happened is it releases okay its energy. I am done to bang heat release it's an exothermic reaction. What is it called? Adsorption ka exothermic reactions. You know exothermic reactions. Heat is released. Exothermic reactions takes place. And what happens is, delta H, okay, becomes less and less. In terms of sign generation, negative. Delta H becomes less and less negative. Delamcha a number to he diwa. Okay, so 2032 energy on release changa. Okay, delta H become less and less negative. Then a situation is reached. In which delta H equal to okay, give free energy what is that? Give free energy del G H minus T delta H. Thermodynamics. Okay. So delta H to T delta S honky bang chat. Okay. Them chang again for spontaneity kile for exothermic delta G has to be negative. Okay, to na theory is all a mechanism. Them chang number to heat. So okay, this condition is called a condition, okay, of equilibrium. This is equilibrium. A condition of equilibrium is established. Then, okay, once equilibrium is established, adsorption process can halt. It stops. Energy release in terms of picture. Energy release. So mechanism of adsorption continues to lie. So chamte di points take le atung lama discussion ini na again sate chamte di te bangale. Okay, adsorption is exothermic process. Yep. Adsorption is so again le absorption is spontaneous process. Spontaneous process chu amale ma pai reactant tem lai tenga tok tana product tan pai external pulama panpina puimolo electric yam bagyam spontaneous reactions. And spontaneous reactions are electrochemistry hintawa. Del G has to be negative. E cell, EMF of a cell has to be positive. Again, vector. And del G gives free energy. Thermodynamics, basic neogic, gives free energy. Expression है del G equal to del H minus d delta S. Del G is give free energy. Del H is enthalpy, change in enthalpy. T is temperature. Delta S is change in entropy. Why not energy is released, like a loss. Then again, adsorption om taka energy is released. Or energy is loss. Why chabangchi delta H value is negative. It is wana ithene ondi. Okay, adsorption process. Absorption of gaseous particle entropy to kisai bangchi. Absorption of gaseous particles. Once it takes place in absorption of gaseous particle, what happens? Entropy also decreases. Entropy chichu randomness. Thermodynamics randomness also decrease, meaning del S is negative. Negative now. Who ya tunglam again? Equation 1 ale koi thei. Okay, del G del H bang hong hita dia. So del G, okay, energy release chenga bang del H, negative del H. Negative omsa T bracket ko del S entropy le negative. Well, minus into plus here plus del H minus negative le. So T del H. Yes. Uchi le del G spontaneous process give free energy has to be negative. Ahile. Ya ilama negative imu thena de banglo de. Okay, this del H has to be more and more negative. Has to be more and more negative. Okay. Positive है, more and more negative ले, ये negative होंगे थे दिमाग है, okay. एक थी श्यामो ये negative दे वाले, ये right hand side का negative दी, ऐसे तो ये plus नम हिंचन. Why we are doing this? Because del G has to be negative. Negative, right hand side negative. Right, and then this has to be more and more negative. Yeah. A point ha jam teolan. Mechanism of adsorption is in teo. A point. Good points. These are good points. Okay. Number bangsa number. Let's involve some numbers. Siam na di na. Vậy trên ông lại lắm. Example. Entropy. Nào anh entropy le negative hay ngay. Chỉ mà chỉ hình ta. Yes, adsorption of gaseous particle take place. Entropy decreases. Meaning this has to be negative. So value bangsa hiam lale. See suppose 10 chine. So okay, minus 10. Okay, entropy is minus 10. Temperature too. Okay, so we will just take 300 Kelvin. 300 Kelvin. This is in terms of degree 27 degree. 25 le lak 25 degree bangsa 298 Kelvin, right? Del H also has to be negative. Okay? Energy kilos le, okay? Absorption energy release ale del H enthalpy also has to be negative. Bangsa HED wala 5000 kilojoule per mole. Okay, good. Del G calculate so minus formula khat begel tha. Very good. Del H is this much. Minus T is how much? This much. Minus 10. Okay, keep inside the bracket. Okay, this is 5000. This is plus 3000. Minus 2000. Finally, del G has become negative. Why am done to del G negative? This is spontaneous. Reaction by the total thing. I lay and point mama. Then again, del H has to be okay. Suppose example. Del H. This is case 1. Case 1 HD1. Again, this is case 2. Okay. Del H ka value ke kole. Say you will make it less negative, which is say suppose 3000 jini. Del S ki bang lai di. Okay, temperature le ki bang lai. Okay. Then 5000 minus. This is 3000 minus del H. Okay, it's less negative. Actually, more or less. Okay, less negative. Okay, del G bang tada enole. Del G is 3000 minus T is temperature into minus 10. Plus 3000. Okay, 0. Del G 0. Why am done to bang? It is the process reaches equilibrium. Right? Okay. case thumna del G value khek non del G is becoming more or less negative. More or less negative see sang thum sang tom so sang ni lani sang ni lagle adang teng ki bang lai del G value bang hi dele ni. So del G is equal to this is positive, okay, 1000. Del G has become positive, greater than 0. Okay, right? Del G negative in on low, negative upon paito and positive on itaka. The adsorption process stops. Okay, the process stops here. Okay. Mechanism of adsorption. Champion, hey, Posun lan, Gelhion lan, copy Hion lan. Money not, keyboard, good. Okay, types of types of adsorption, right? Types of adsorption, it has to be the basis. Okay, depends on the types of attraction between adsorbate to adsorbent. Why reactions like chemical bond bang yang to say division ni bol ngaita male okay khatna okay so now gelu to le on the basis of the types of attraction between the adsorbate and adsorbent. The following types of adsorption are given below. Okay, so why see the types of attraction. Okay, adsorbate to adsorbent ki kala attraction. Van der Waals forces, attraction, khatama. It's very weak forces. It's intermolecular forces of attraction. Okay, lower class IT done. Intermolecular forces. Suppose if van der Waals hydrogen bonding chite, it's a very weak bond. So what can you write about this van der Waals? Okay. This is intermolecular. Molecule khatle molecule dang khat kikala interactions. What is it? Strong law. So intermolecular force of attractions. Next point. It is a weak forces. It is a weak forces between two molecules. It's a weak force and it is between two molecules. It's a kisukha to amai molecule ni. Okay, it's physical forces. It's basically physical forces. Why is yaktaka yai van der Waals attraction tungto na adsorption hong piang chubang. It's called Physisoption. Physisoption. Physical forces. Okay. So idea comes from what? It's a physical forces bond. Physical bond. So khatna bang types of adsorption khatna Physisoption. And now ten ole e bang di di naging tao adsorbate to absorbent ki kala bond omdang when the was khat hile ani na. Okay, due to chemical bond. Chemical bond le thailo telai vale ha ki kalwa absorbent to absorbate. What is chemical bond? Point kharna bang, it's interatomic molecule khat sunga atom to atom ki kal vale why jaka hat vale it's intermolecular hinon lo interatomic forces or intra lekiche intramolecular forces. Example te ko bang covalent chite bang very strong bond no like covalent bang ionic bond okay van der Waals sanga they all stronger bond. Okay, that is why it's due to chemical bond. That is why this type of attraction is very strong bond. Example may enle OH high water simplest O to H ki kala covalent bond ye break na dia energy tam pingai mane. Okay, it's actually then van der Waals ichi lama suppose water molecule hydrogen bond formula H and O is forming bonds. Okay, hydrogen bond. This is intermolecule ye bond ha weak so heat jagle the bond will break. So this is hydrogen bond which is van der Waals. This is your covalent bond which is very strong. It's because of chemical bond between them. And chemical this type of attraction is very strong, very strong and is permanent. Is permanent had be omden, and therefore it is called bang chemical bond akipan again sorption on the fisi hinolo chemissorption siang tama ma din ging ta chemissorption. What is the basis? It's because it's chemical bond, chemical forces or bonds. And physisorption, it is a physical force or physical bond. Next. Okay. Adsorption isotherm. Adsorption isotherm. Isotherm is iso means same, therm means temperature. At same temperature. At same temperature adsorption phenomena. Okay. So adsorption isotherm basically it is all about pressure, effect of pressure contribution pressure contribution on adsorption. Keeping what? Temperature constant. So point number 1. This is about what? This is all about effect of pressure on adsorption, keeping temperature constant. Point by point in koy. So at constant temperature, experimental observation hai. What they find is at constant temperature, the amount of gas of gas adsorbed on the given amount of adsorbent on the given amount of adsorbent on the given amount atang 1 gram, this is 1 gram of adsorbent gram khat adsorbent a gas bangza ki adsorb, yes, at constant temperature. The amount of gas adsorbed on the given amount of adsorbent is dependent on what? Pressure. See, contribution of pressure is coming. Pressure in part play adsorption isotherm. It's all about what? Effect of pressures on adsorption. Why am done subang is pressure increases, amount of adsorption will increase. Suppose this is your adsorbent, adsorbent, sorry, whose mass is 1 gram. Given amount 1 gram of adsorbent. Suppose, gas molecule they get adsorbed. So whose mass is say 0.2 gram of gas. Okay. Adsorbent and exactly as charcoal. Gas there, see, suppose this much amount is adsorbed. Okay, situation create nile khatna bang. Say suppose at 2 atmosphere, okay, pressure unit ha atmospheric. I kill bar at 2 atmosphere or bar. Okay, let's say 2 atmosphere. So at 2 atmosphere at constant temperature, say we'll take how much temperature 273 Kelvin, which is okay 0 degree China. Boil out 273 Kelvin, it is 0. Basic 0 degree centigrade is equal to 273 Kelvin. 0 degrees centigrade is equivalent to 273 Kelvin. 25 degrees centigrade is equal to 298 Kelvin. Right? 27 degrees centigrade, 300 Kelvin. So, suppose you have taken 2 atmosphere of pressure and temperature 0 degree, okay, or in other words 273 Kelvin. And it's how many gram? Say. Okay. So first we will 295. Suppose khatna temperature the next step ahi temperature has a lapod de. So okay 298 okay 0 lapod de ke paila so 273 Kelvin, and then say at 0.4 gram of gas is absorbed. Gas is absorbed. That's again 0.4 gram of gas is absorbed. Next, pressure increase, let's say 3, and okay, temperature is still the same. At constant temperature, temperature is still the same. And suppose you will see again higher amount of gas will be absorbed, say 0.7, Why am done bale? pressure na increase le, amount of gas adsorbed increases. Why to adsorption isotherm? The main idea. Yeah. Okay, jump this illustration. Jump okay. So why not a poem non adsorption isotherm? Dem chile graph draw chang. Has a dimama bangayam chile. Yeah. Okay. Point ni nai jump the bang. Extent to bang. How much degree gas is adsorbed? Extent of adsorption, right? Adsorption. Extent of adsorption. This is given by x by m. X bangala. X amount of gas absorbed. Amount of gas absorbed. B absorbed. Okay, mass. This is what? Okay, mass of adsorbent. Given mass, suppose 1 gram. Then I like that. Okay. 1 gram. Extent of adsorption is given by this formula. This one. Okay. So chamte di x by n. X is what? Amount of gas adsorbed. M is what? Mass of adsorbent. Given mass of adsorbent, right? Graph draws it there. You know that. So y-axis, extent of adsorption. X-axis what? Pressure, right? Adsorption isotherm is all about the effect of pressures on extent of adsorption, right? Suppose a graph na modidan khachidan hai. It's not straight line. Okay, first, okay, it is linear, curved, then it will be constant. Then check okay, mechanism hoy tagani gel no diwa bangje ka linear here ga bangje curve hoy bangje constant happen. Explanation them check. Suppose this point, alright? Okay, let's write this is it has become constant. Okay, linear and exponential curve, then constant. Suppose here point this is pressure, x-axis is pressure. So this is called okay, PS, saturation pressure. PS, please. Okay, PS, what is it? Saturation pressure. Yeah, hong pai to, hong curve to. But from this point, yakipana a graph pen ka straight ta. Akipan a straight line kipan na bul. It's called saturation pressure. Saturate yakipana a process of knowledge jena. Okay, adsorption process stops jena. Okay, so it's called saturation. Yeah. Amount x is given by this x by m. Pressure is over here 0, and then it goes up to PS, and then the graph becomes straight line. Easy thing bangale yakhat na. Okay. As P increases, pressure here. Velam to velam ki pat taklang pipe here, pressure increase. Pressure increase. X by m le increase. Can you see? Increase to. Okay. X by m also increase. Dik. Pressure increase le x by m. Of course, but not linearly. Tang taka increase to hilo. Had it been like this, it will be linear, but not linearly. Right? At point PS, point number 2. At PS, or which is called saturation pressure, or saturation point of pressure. Saturation pressure point curve is constant. The curve is constant. And okay, what is this? This is pressure saturation point. Okay. Pressure saturation point. This saturation pressure. So you can hear this is saturation pressure. This is saturation pressure saturation point. So, and at pressure saturation point and at pressure saturation point, saturation point, adsorption reaches, adsorption process reaches what? Equilibrium. Equilibrium, right? Then it become straight line, right? So yeah, it point. So at equilibrium, what happened? At equilibrium, okay, these two processes has become equal. What is that? Adsorption. At equilibrium, adsorption is equal to desorption. Desorption. Kibang chat at equilibrium, right? Siamte wala ya. Abana. Yeah. Friendly, isotherm. German tea. So pronunciation le tom de ma. Okay. Dium de FREUND. Friendly LICH. Friendly isotherm. Okay, question khatam ma x by m, which is equal to constant, and the pressure to the power raised to 1 by n. Yay, okay. Friendly isotherm. It is you read like this, where x by m is extent of adsorption x is what? Amount of gas adsorbed, m is given mass of adsorbent, P is pressure, K to N, it's a constant. Constant, K and N are constant, whose value depends on? Whose value depends on the nature of adsorbent. The adsorbent atua male, K to N value tuam. Nature of adsorbent and on the gas, nature of the gas. A gas atua male adsorbent to adsorbate atua male K to N value te kihek. No. So that is what it means by constant value whose value depends on. Constant whose value depends on this. Okay. X lama x by m, extent of adsorption, y lama pressure. Suppose let's say 273 Kelvin. Temperature at this temperature, how does the isotherm look like? Initially, and then curve and become straight line. Okay? Temperature danga say 244 Kelvin. Temperature decrease. 195 Kelvin. Now, okay, and all then PS equal namuno. Okay, at that point where that curve become constant. Suppose then roughly in this will be your PS saturation point, and suppose 1 atmosphere. Let's just take one at this point. Say at 1 atmosphere, constant pressure. Point. So x by m y axis lama yai de only here. Okay. Yeah, bangai shin thei chile khatna. At constant temperature, no pressure here 1 atm. Constant pressure. As temperature decreases, 273, 244, 195, temperature decreases. As temperature decreases at constant pressure, bangale you observe. Okay. X by m, this one, x by m, the y-axis part, okay. It increases. Yes, temperature decreases, and at constant pressure, the x by m value increases. Good point. When the 2x by m is equal to k by p, suppose then I get some x by m equal to equation 1. Yeah, keep on p 1 by n, right? X by m is given by this and increase. Yeah, Neihsial studies only. So take logarithm. Taking logarithm, natural log, obviously natural log. So ln x by m, ln log of ab is what? Is equal to log of a plus log of b, ln b. Product log of any two product of two terms is given by this. Okay. So this is two terms. Product of these two terms will be ln k plus log of p 1 by n. Good. So ln xm khabigil thako ln k plus ite sao, okay, a log of say a to the power n. What is it? The power comes here and then log of a. Why dana? Yeah, 1 by n by here. This one. Okay? Can you see this? 1 by n is coming and log of then log of b, right? Now straight line intercept form. You remember the equation of straight line in intercept form is this. C is the intercept, m is the slope. Yes, slope. This is the y-intercept. This is the y-intercept. So this part can be given as y, and leuchin here mx. So you can write your mx plus c. Plus in so the slope is this part. This whole thing is your c, and the x is this part. Why am done to graph a draw summation? What is my m? The slope is 1 by n. C is ln k. Graph draw now. This is, suppose you draw a graph here. Y-axis is this. Y-axis lama ko agaldi. Ln of x by m. Okay. And this Y is what? Y-intercept. Suppose this is your Y-intercept. What is the value? This is ln k. ln k. Okay, and you draw like this, and take a slope for this line, so somewhere, any point. Okay? So your slope will be equal to 1 by n. This is your slope, 1 by n. Okay. X-axis lambda. X is what? Yellow color. X is ln p. Okay? This is ln p. X-axis. So a graph can be drawn from this equation. Basic. Okay, so it's coming from here, and then this one. Fromlich isotherm, detail takin study Siamkhanthang, okay, posun lan, gel hion copy hion A discussion talks 1 by n. What is this 1 by n? What is this 1 by n? Then I again sabang na. N is a value which depends on nature of the adsorbent and adsorbent, right? This is the slope. We can say this is the slope. And experimentally, 1 by n value is from 0 to okay, 0 ke बाद 1 ki kala value lagi ke. So khadna say suppose at very low pressure, what happen is at very experimentally at low pressure 1 by n value has become 1. Experimentally observations, experimentally Why dan chubang bullama x by m. What is that? X by m equal to k p to the power 1 by n. We have this. X by m equal to k into p 1 by n 1 okay. That means this is the first order chemical kinetics here. Okay, first order kinetic reactions. Yes, first order kinetic reactions. When then talk to constant coilan, okay, xm by m is directly proportional to this pressure. When then bangchi directly proportional. When then talk to p increase le, if p increase, x by m value also increase. P decrease le, x by m also decrease. Of course, linearly. Then a graph draw. Linear bangzeka straight hong pot wachang curve. Again set number. This one. Linearly. Intermediate pressure. Let's see. Second point. B. Intermediate pressure. Intermediate pressure, what happened to the value of 1 by n? Experimentally, what defined is 1 by n value ranges from 0.2 to 0.5. When done to our isotherm, Fromlich isotherm x by m k to the power p is say suppose 0.2 or 0.5. Okay, I call 0.3 hong this is no more first order. First order kinetic in all. First order kinetic in all. So it's not linear. First order kinetic not linear. Not linear anymore. It's no more. Okay, there's no more linear growth. Okay. It may be what? It may be exponent. exponential growth hitare. Why he dena graph ye tuma? Okay. First, when pressure is very low, it was linear growth. When P is moderate, exponent growth, right? Exponent growth. Okay. C na enole. C na bangche high pressure. Pressure value pressure high chang bangchi 1 by n value has become 0. Experimental observation here. 1 by n is 0. Which is x by m equal to k, p equal to 0. Okay, anything to the power 0 is 1, we know. X to the power 0, 1. Anything to the power 0, 1, 1, 0 to 1. So x by m equal to k, because this one is 1. X by m equal to k. Okay, since p0 equal to 1, right? So that means what? K is a constant. X by m is equal to constant. Yes? Why he? Exponential growth bana yakipan ha constant na pen. Male? Sele constant? Adang la itele constant. Yes? Constant from here. Constant. Initial growth when the pressure is less. When pressure is more moderate, it is exponential. When pressure is high, it is constant. So revision chile, okay, graph entakalena, okay. So when x by m, okay, this is pressure. Yemuna, okay, low pressure. See, this is intermediate. This is high. Okay, it's a low lighting straight line, linear growth. Intermediate. Exponential growth curve, then straight line. Okay. Catalysis. You have to get on there. Catalysis, right? So catalysis to say story lunglut hoy ma khatanama. Mikhat amin Bergelius, Bergelius, Bergelius kichi khatanama. Okay, what he did was he studied the effect of foreign substances on the rate of chemical reactions. Okay. A compound like potassium chlorate. So he took potassium chlorate, formula is KClO3. Okay. Two molecules, balance again. Two molecules, products are KCl plus 3O2, right? So 653 Kelvin on heat tile. Okay, yaki kala product ki forms gige ambol 873 Kelvin. Temperature yaki kala yai chlorate dissociate changa yai product pechat ma. Okay, ucha hama athilo ha by mistake accidental compound khat MnO2 kichi khat ClO3 on hel khamok okay akhuta bangya cha by bottle te chemistry lepa bottle te ba khoi khain cha khuta kipan lut khalai the ma accidentally MnO2 khanom why pot casual himai the hong pai ki ka kha a product na ki form same product but temperature ha tom chik okay say suppose 473 akipat 673 ki kal product na ki form an motaka maksalwa ma ngai to le this manganese dioxide nom da ne What he wrote? He observed what? Okay, he observes. Okay, Mn number 1, MnO2 does not reacts low, or participate low, react low in the reactions. Observation number 1. 2 na, due to the presence of MnO2, reaction take place at lower temperature. Temperature tomta si tunga 653 Kelvin, now 473. Lower temperature, even at accelerated rate, faster. Temperature tomde there, but at very accelerated, very fast reactions. Mama MnO2. So honai tota huchi takakha man, okay. So he coined the terms. Give the names to this substance. He didn't call he didn't call this. He called this MnO2. He gave the name. Okay, catalyst. Then he defined catalyst as what? Okay, he defined catalyst as. Okay, so yes, again, it's a substance. Catalyst is a substance which can altered jichu fast sakthi, slow down the, speed up the, may either increase or decrease, which alter the rate of reactions without chemically participating in it. Participating in the reactions. Again, these his definitions. Okay, catalyst to again komkomin. What is promoters? Okay. What is poisons? And what is promoter? Example. See, in industry, in industry process, what happens is production of ammonia is done by Haber process, right? Haber process. Why bangale? Haber process. Nitrogen to hydrogen kiriyekun ammonia produce. Ammonia is fertilizer. Okay, industry Haber process is used for production of ammonia, fertilizer, ammonia, right? This is the reactions. N2, 2H3, balance it. Okay. Why catalyst I use Siamkhanthang iron catalyst. This is the iron. Okay. Siamkhanthang, okay. Promoter, that is molybdenum. This is molybdenum. Okay. He acted as a promoters. What is promoters? Let's define formal definition. Penile promoters is a substance which enhance the efficiency of a catalyst, which enhance the efficiency of a catalyst. He promote molybdenum in iron panpi he promote, which enhance the efficiency of iron. So molybdenum is a promoter, catalyst is iron, right? Poison bangale. Poison to opposite react. Okay, so poison you can define like this. Poison is a substance which decrease the activity of a catalyst. Tuma example laga iron. Oi jaga industry ammonia industry kim lakianga carbon monoxide om dekha de hello unchen. So inhaber process of production of ammonia, carbon monoxide is a poison. Carbon monoxide in iron sepdibang bang siam sakthelo. So toy. So question GK kholang pai mal, why is CO what is the activity of CO in Haber process? Ole tu Neihsial lim na di he sai ya